Let's get started for today. So I have the honor of introducing my friend Kjetil Storesletten. I first encountered Kjetil almost 30 years ago reading the job market packet. You were out maybe 2 years after me, and from Carnegie. There was this guy from Carnegie who was going to solve our Social Security problem with immigrants. And it turned out you were extremely farsighted in your choice of research topics. That was one of many great moves that Kjetil has made throughout his career. He has also done path-breaking work on rich sharing, income inequality, and a line of work that we all know him for is exploration of Chinese growth and the Chinese economy, which I believe he'll be speaking to us about today. So I don't think you need any more introduction. Please take it away.
Thank you very much. It's good to be here. It's beautiful. I like this conference. It's a beautiful location. So that's good. So this is, I'm going to talk about the economic slowdown in China. This is joint work with Brandt, Kishan, and Wang. So a lot of people say, oh, China is slowing down. There's a slowdown in growth and TFP after 2007. Is it true? You know, we don't know. I'm going to argue that it is true. Mm-hmm. But then if suppose it's true, why would it be? What are the stories that people have in mind? Well, people say, well, there are two types of stories. One type of story is that, oh, it's something that would have to happen anyway. It's something outside of China's control. You know, there's a worldwide slowdown in the TFP growth in manufacturing, for example, or something you see also in the US and Europe, or perhaps the low-hanging fruits are taken, or perhaps in another paper, perhaps by moving close to the frontier, it's going to be more difficult to adopt existing technologies, and we have to do more innovation. Anyway, there's another type of explanation that China is doing something wrong. There's something. The slowdown is caused by government policies, or misguided government policies. Saying we're under the hooding that government policies are becoming less GDP-oriented, less growth-oriented. So, say that the anti-corruption campaign that Xi Jinping set in motion when he took power, the fiscal expansion associated with the financial crisis, boom-bust of the real estate sector, etc. So, what those type of explanations have in common is an idea of, say, the return of firm-level distortions and barriers, stuff that people argued that leading up to the financial crisis, part of the growth, if you think of Kjetil and others argue that distortions were going down in China over that period, and perhaps those are coming back. And a number of people have argued that the growth miracle in China was very much due to the creation of new firms. Will we be able to speak to that? It would be nice to be able to speak to that and see to what extent, if there is a slowdown, to what extent that comes from exit, entry, or incumbents, etc. Or another type of explanation is that, oh, it's really misguided industrial policies. Say, size-based policies that the government favors large firms or small firms, or the government keeps certain geographical areas or certain now, what we're going to do in this paper is take on the data challenge. So we're going to build a representative data set for Chinese manufacturing until 2019. I would love to continue. I'm going to tell you later about why we stopped in 2019. Once we have that, we're going to study productivity growth and factor-saving bias in manufacturing. And we're going to use the data to take a bottom-up view. We're going to identify labor augmenting versus Higgs neutral technical change. We're going to study the role of size and churn, so reallocation and churn exit. And we're going to propose a novel growth decomposition between efficiency and misallocation. And I'm going to sketch out what the aim of this work is to do something along the lines of what Diego did yesterday. The aim of this work is to estimate this model, estimate a Hopenheim version of this model with a number of where we allow the parameters to change over time to match the changes in the firm level distribution and use that to somehow do counterfactual analysis and ask what is it that caused the slowdown. Good. So here's why we need, here's the data challenge. The national accounts are probably exaggerated, at least that's what authors such as Xie and Song argue. So what we would need, if certainly we would like to, the ideal thing would be to have a representative firm level data set to calculate TFP at the firm level and aggregate that up, and then be able to see somehow how the firm level distributions change, etc. So I have to say, what I'm going to say today is very much consistent with Diego. What Diego did yesterday, I'm going to talk about. I'm going to mention that in various places. So there are three data sets. Suppose you're interested in China. I think you should be, given that it's a quarter of the world economy, and given that we know so little about that economy, and then there's so much exciting stuff that happens there. So now there's three data sets, firm level data sets you could use to study China. The NBS, or when people talk about firm level data set in China, they usually talk about NBS, National Bureau of Statistics, has a data set on so-called above scale firms in manufacturing. And almost everything you've seen on firm level analysis in China uses that data set. It's a very good data set until 2007. So that's why everything you see is until 2007. So what happens after 2007 is that for some reason the accounts are we believe that firms overreport. So for example, once you get to 2013, if you add up the value added in the NBS, which is just for the above scale firms, that is much larger than the aggregate value added in manufacturing according to the national account. And there is another problem. Those data end in 2013. No one have NBS data after 2013. Right. There's another data set. The National Tax Bureau has data, good measurements, but for a sample of firms. And for example, in 2007, it's as much as they cover as much as 1/4 of the firms. In manufacturing, it falls to about 8% by 2019. The problem with those data is that it's not representative. Something I'll get back to. So oversamples older firms and larger firms. Then there is another data set that not too many people use, the so-called inspection data. It covers the universe of firms, but it has very not very detailed measurement per firm. Yes. So what we're going to do basically is we're going to combine 2 and 3. We're going to use the inspection data to correct the weights in the tax data, and then use that as a representative. Yes.
If I understand here, the goal now we're going to go is try to measure firm level TFP and changes of that. What I don't understand is how you can say that that is real firm productivity, or not the fact that the firm is receiving subsidy from the government, or some favorable laws, or the government just buying more stuff from them for political reasons. How can this distinguish TFP from other benefits from the government?
Well, I'm going to see allocations. I'll see the allocations. So this is a macro seminar, remember?
Yeah, no.
Okay. I like that question, but let me get back to it, because I'm going to try to talk about that specifically. Yes.
Just a quick data question. So, do you know what data the Chinese use for the national accounts? I guess some of that data they also use. They don't have a fourth data set that's the perfect one or something, right?
What goes into that sausage? I wish I knew.
But you don't know.
I think they use all of these.
Exactly. And then they must.
I think the people who do the national account, they do their best, but they're under political pressure.
Yeah, exactly.
You know, what would you do? Imagine somebody said to you, look, Jonas, I wanted to do the national accounts for some random country, let's call it Norway. And then when you're doing doing your best, the president of the country, which by the way could put you in prison if you don't deliver, says, well, I guarantee you that next year the growth rate will be at least 5.2%. Turns out China meets the growth targets every year.
I guess in Norway you just count salmon and gas and then.
Okay.
So if the original question is about GDP,
GDP growth, yes.
GDP growth, should we care about sectors other than manufacturing as well?
I would love to, and that's
Services.
obviously I would love to. Now the data are a bit better for manufacturing, so we're starting with manufacturing, but we are in the process of doing the same stuff as we do here for services. So the answer is not yet. Next time you see this paper, perhaps. So okay. So here, what we call the tax data. No, there is no.
I mean, it's on my laptop, I guess.
Okay. So the NDB data, as that collected by tax authorities, it's basically the government tries to tax its tax accounts basically. And I think those data are good because the firm does not have an incentive to over-report because then they would pay too much taxes, and the government does not have an incentive that the firms under-report because then they will get too little taxes. The purpose to tax the value-added improvements. There's a register data, which is if you have a corporate firm, you need to, or a limited liability, for example, you need to register it in China. And if then you are going to be in this registry. I don't think that informal firms is a big problem in China, certainly not in manufacturing. And then you're going to be in those data, and those data keep full account of when you enter, when you exit, where the headquarters is located, and the vast majority is single establishment firms, and the ownership type. Now, when the same agency that collects that holds the registered data also inspect firms to check that they operate in line with the license, and then they ask firms. The firms self-report, for example, revenue and assets, and some other things. And they are the values that we're going to use. Then this is from those inspection data. We could, in principle, go back to 2003 for the tax data, but the inspection data are good or relatively comprehensive only from 2007 onward. We stopped in 2019. I would love to go on to 2024, but the government just took away those data. So I think it's relatively sensitive what happens from 2020 on. For the period 98 to 2007, we're going to use the standard data that everybody uses. All right. Then let me try to argue that the inspection data and the tax data are of high quality. So let's look at the stuff that's reported in both places, aggregate revenue and assets. So here what I've done is to I've taken in the NTB sort firms and match all the firms that are in the tax data with the firms with the same firms in the inspection data. I've sorted the tax data firms into percentiles, and for each percentile, I calculate the average revenue in the NTB and the average revenue in the inspection data. And I plot a bin scatter plot. As you can see, it's the same number that's being reported. And the same thing holds true for assets. The red line is the 45-degree line. It's just for the lowest 1%, there's a slight deviation, but for everyone else, it's exactly. And by the way, if when you have two mismeasured entities, two mismeasurements of the same thing, for example, revenue, it's really easy to estimate measurement error if you assume that measurement error is classical, i.e. independent in the two things. If you do that, you find that in NTB, the variance of the measurement error is less than 0.2% of the total variance. So that's small. It's a bit larger in the inspection data, but would still be lower every year than 5% of the total variance of revenue, and it's similar for assets. Good. Now, then we need to adjust the inspection data a bit. So we have to. So now the idea is to use the distribution, the empirical distribution of revenue and assets for the universe of firms in the inspection data to correct the tax data, to correct weights for the tax data. So now look at the total. There are some problems with inspection data. So for example, there is a huge number of fake firms. We have to remove them. So if we look at firms that never report any revenue or any assets, we assume that they are fake firms, and we take them away. And we adjust the entry and exit dates. For example, suppose you stop reporting revenue and assets in 2015, and then in 2019 you formally drop out. Then we say, oh, you probably dropped out already in 2016. So we adjust the entry and exit dates in line with the reporting. And if there are missing intermediate observations, we impute them using the K nearest neighbor. K nearest neighbor. Okay. So here's a little comparison of the inspection data. So you should think of the inspection data as the universe. As in manufacturing, as you can see in 2008, you had about 1.2 million firms, which is actually very low. And that doubles almost by 2019. There's a huge growth in the number of firms. And let's define, and then the scale, the share of firms that are quote unquote above scale. So from 12 and onward, that means that they have sales more than about $2 million. It's falling slightly over time. And the entry rate into the data is close to 12% early on, and that falls to about 8-10%. So entry rate is falling, but it's still, these numbers are very high compared to the US. The entry rates would be like 4 or 5%.
But you think of them as real entry? Like,
I think of them as real entry, yeah.
It's not that then the data just collects some firms that were previously missed or something like this?
No, that I don't think, and we have, so if we included every firm, the entry rate would be much, much larger. But I've taken out what I think are fake firms. All of these firms report something.
2008 is maybe you would expect that there's a global financial crisis. Because that's a forward-looking decision, no?
That's right. So 2008 was a tough year for the world, also for Chinese firms, and that's why the government set in motion an enormous stimulus package. Which you'll see actually accelerated growth during those years. All right. But if we look instead at the tax data, you see in 2008, it's just they collected about 1/5 of the firms. 60% of the firms were above scale compared to just 40% in the inspection data. So the NTB oversamples large firms and it oversamples older firms. And by the way, it is the tax data are firms stay in the tax data for relatively just for a couple of years. So you should think of it as a repeated cross section. So if only the tax authorities could tell us how they did that sample, If they did that, that would be super simple for us, because then we could just reverse engineer and get the true weights. But they are not willing to do that. So that's why we have to instead pursue the following weighting strategy. So what we're going to do now, it's a semi-parametric strategy. So let's take the inspection data as the truth, sort firms in a bunch of bins based on, say, year, the size of the firm, the age of the firm, and the industry they're in. So 10 industries in manufacturing. And for each bin, we count the number of, for each bin, we look at the distribution of revenue and we look at the distribution of firms in the inspection data, to take the truth, and in the tax data. And now we want to reweight the firms in that bin in the tax data so that it matches the distribution of assets, age, and revenue in the inspection data. That's the strategy. There's a problem though. So when you compare, when you estimate densities, there are many cases we just did it purely non-parametrically. There were many densities that would be close to zero, and that's not fun to divide by zero. So what we instead do is to estimate those density ratios using a least square importance fitting, which is standard in that literature. Good. So you might ask, how good is the fit at the end of the day? So this graph shows let me do it for revenue first. This shows the marginal distributions after having done the simulation, and then I'll look at the marginal distribution of revenue. If we pick a particular year, for example, 2016, the blue, so on the I have log revenue on x-axis and density on the y-axis. The blue is the density in the tax data. The red is the density in the inspection data. As you can see, the tax data are shifted to the right big time. So it should be illegal. You cannot use the tax data willy-nilly. You have to do some kind of adjustment. Now, the green is our simulated data. So if you look at scale, the above scale, sales of $1 million is about here. If I forget about the lows, you see that the fit, the simulated sample captures the empirical really well, and this holds true for every year. If I look below there, oversample undersample the smallest firms and oversample somehow firms that are in the middle. So here would be sales of about $5,000 a year. So really tiny firms are just not in the tax data. So therefore, we struggle a bit of capturing the smallest group. Just keep that in mind. In terms of age, we do a much better job at capturing. Good. So once we've done that, let's take a first look. Let's take a first look at the data just to see kind of what's there. So here I have. There's no theory here. I'm just plotting the. Let me just say. In the tax data, I calculate value added using the income approach. So we look at the payments going to labor, payments going to capital, and payments going to the government, and add that up and call that value added. It would be nice to instead use the production approach, but for about 1/3 of the firms, we miss the purchases of intermediates. So and the reason is that not so there is a VAT system in China, but not all firms, not all sectors are covered by the VAT. So many are missing. Good.
Sorry, how do you see payments to capital?
Well, that's a residual. We'll look at profits, accounting profits. Okay. Good. Okay, so if you look at revenue or gross output. So before in manufacturing, 98 to 07, it was growing at almost 21% per year. So that period, was characterized by ridiculously high growth. It's perhaps slightly exaggerated because it is the growth of revenue of the above scale firms. So if many firms went from being below scale to above scale, that would kind of add to the growth. And the growth in value added was about the same. In this data, if you look at the 2017 to 07 to 19, you see that the growth is down to about 1/3 of that. And if you look at value added, the growth is a little higher, but still a massive slowdown. So yeah, we conclude that it's true that China did slow down substantially in manufacturing, at least after 07 relative to before 07. If you look at that, this holds true also if you look at the input. So employment growth was was almost 5% per year. So manufacturing was expanding at a hefty clip, and total assets was growing at 13% before 07. That growth falls after 07, and for employment it's negative growth. So there is structural change out of manufacturing after 07. However, if you look at wages, if you just calculate wages per worker, you see a really fast growth. This is the normal wages. Really fast growth before 07, 12%. It falls a little after 07, but not very much. So we immediately see if the wage growth is more or less a constant, but the value-added growth falls a lot. It's clear that the payments going to labor is going faster than GDP. So after 07, the labor income share was increasing very fast. And before 07, it was falling very fast. So in manufacturing in the US, the labor income share has been falling for quite some time. And in China it was falling also, but much faster than the US. And then that reverses after 2007. Okay. And if we split now, if we look at the period, split between 07 to 11 and 11 to 19, you see that until 2011, that was regarding the question about the financial crisis. No, it was the financial crisis. Things did slow down a bit, but the big slowdown was really after that. After that time. Of course, employment growth is much more negative.
Question. In this period, China also has been increasing a lot of human capital accumulation.
That's right. And that contributes to this growth. Mm-hmm. Clearly. Yes.
Since employment is falling, this doesn't mean that a larger share of the output goes to labor, right?
That's right.
The wages may be going up, or
yeah, exactly. So you have to. So if you do a really approximation, just add those two numbers, you see that this is the wage bill is growing at 10% per year, and value added 8%, non-value added. So it means that over a 12-year period, the labor income share was falling at almost 24%, which is the labor income share increased by, I think, 10 percentage points, which is big. All right. Now, I said I wanted to, I was interested I want to know somehow, where does this slowdown come from? Is it, entrance, exits, incumbents? Is it large firms, small firms? We like to see that. So I could, in principle, just go to look up some textbook on firm dynamics and see what would they do. So here's a straw man. Imagine I just assume, say, Cobb Douglas, put a function with a constant return to scale. And then we define aggregate productivity, Z, as the sum over firm level productivity with constant to scale, that's kosher. And with those S's would just be the input shares. And then I could do a Bailey-Houghton-Campbell decomposition of added productivity growth, where the growth in added productivity, or say the solar residual or something like that, would be like a term, the within growth for incumbents between growth, so whether the more productive firms are expanding or not. Entry, whether entrants are more or less productive than incumbents, and exit, whether exiters are more or less productive than the incumbents. And a couple of problems with this approach. First is that Cobb-Douglas seems very, given you saw the big changes in labor income share, it just seems like the wrong place to start with the Cobb-Douglas, where I assume that the labor income share would be constant at the outset. And it also seems crazy to assume constant time to scale production function because it's a little meaningless to talk about the firm size distribution if you have constant time to scale. All right. Then, moreover, this formula ignores distortions and misallocation. There's no. We'd like to know. We'd like to know, for example. So this term captures some kind of reallocation, but is reallocation good or bad? Well, this formula doesn't say that. And there is no role for the number of firms either. And conceptually, by thinking about incumbents versus entrants, a very stark comparison there, it ignores potential interaction between entry and incumbents. And I'm going to argue that that's when we're thinking about entrants. I can tell you now already, entrants are going to be bad according to something. I'm going to correct that formula, but I'm going to find that even when we do that, it looks like entrants are bad. However, once entrants are going to grow. Once they've entered, they're going to grow really fast, and they are the ones who are going to contribute to why incumbents have such a high growth contribution. All right. Good. So here's them. So now is the time to return to Gosman's question. So I'm going to assume this production function. This is going to be a version of what Diego did yesterday. I want to have a production function where I can have large changes in the labor income share without having to do all of that through changes and distortions. So therefore, it's natural to start with the CES approach. I'm going to insist on having the same production function for all firms because only then does it make sense to compare TFP growth across firms or across groups of firms. And so we could of course do if there were no frictions. It's so easy to do economics because then we could just apply Hulton's theorem and we wouldn't have to make very strong assumptions about the production function. But I'm going to insist on I'm interested in specifically distortions. So that's why I'm going to go with this. So I'll assume that there is a firm-specific Higgs-neutral component, like Diego did yesterday, and then it's going to be a common component. Lambda T is going to be labor augmenting growth. It's going to be the same for all firms. Okay, then I'm going to assume that all firms face output and capital friction. So the distorted problem, they maximize something like this, along the lines of, this is what Diego did yesterday was to have an output wedge, but no capital wedge. I'm going to extend that with allow also for capital wedge.
So Kjetil, one question. So an alternative to the CS will be like if in the data, I guess what you see is that the labor share is rising across all industries in the manufacturing sector.
After 7 years.
Yeah, okay. Because otherwise you could just have Cobb-Douglas, but shares being different across industries, and then the composition is relevant for that.
You're right, but that's not enough. Because even within industries, there are large changes. But I agree with you. I ought to. We have not done this analysis at the industry level, but we really ought to do that. Okay, so if I solve this problem, I'm going to have two first-order conditions, one for capital, one for labor, and that allows me to, and you can see that allows me to, the labor income share at the firm level is going to depend on the distortions now, and on the D parameters in the model. Now, I want to have a notion of aggregate TFP. Suppose I'm gonna arrive at something similar to what Diego had yesterday. Imagine all firms are exactly the same because of this eta is a number smaller than 1. There's the equation to scale, and therefore it's going to be optimal for all firms to have the exact same share of capital and the same share of labor. So each firm then. This is the output per firm, where this X is just this constant return to scale aggregation of inputs. Aggregate output then is that the total number of firms times output per firm, and I can write that like this, and then solve for Z, which is the notional aggregate TFP per firm is value added. It's value added per firm over inputs, over the inputs in each firm to the power eta. And I can write this like this, where I just take aggregate output over the input aggregator, where I take aggregate capital, aggregate labor to the power eta, but I have to include the number of firms to the power 1 minus eta, because it's as if firms represent a fixed factor. It's an investment. Good, so what I like to do now is I would like to estimate that lambda. The problem is that because of distortions, the labor income share, for example, depends on the firm level distortion. So if I could vary those freely, I cannot use the labor income share or change the labor income share to impute what the lambda is. So I need a strategy to do that. So I'm going to make two assumptions. First, I'm going to assume that I need to normalize somehow the lambda. So I'm going to assume that in the initial period, wages do not contribute to the labor income share. That's just a normalization. And then I'm going to assume that for firms that are 5 years or older, the labor income, the output wage is constant over time, over the life cycle of the firm. So the idea being that there might be some stuff that there might be output frictions that vary with age, the first in the beginning, but after 5 years, it's constant. Yes?
I think in the very beginning you started with this anti-corruption campaign as one of the drivers.
Yeah.
Would that not violate this idea that after 5 years this corruption campaign can still enter and distort this?
So, perhaps. I mean, I have to do something. It's a similar to, if you want to talk about, if I allow for unrestricted measurement error, we can just go home. So I have to do something. So this is the smallest assumption I can make and still be able to. The alternative, I could abstract from output wedges. That would be easy. But at least there are okay, put it like this. When we calculate the empirical output wedges, it looks like there are not much change after 5 years for. Okay, so if I then take the first order condition, I can express the output wedge as a function of observables and the lambda, which I'm interested in. If I integrate, so now the problem is, I don't have a panel data set. If I had a panel data set, it would be very simple. Given the assumption of constant output wedges after 5 years, I could just take first difference. but it's a repeated cross section. So, but what I'm going to do is to exploit a trick from labor economics of synthetic cohort. So since I have a representative sample, if I look at firms that are, for example, 6 years old in 2012, then I'm going to look at firms that are 7 years old in 2013. That's the same population. So I integrate that equation over all incumbents in 2012 and 2013, take the ratio. Now, this integral now, given that they're sampled from the same distribution, this ratio of integrals for t plus 1 and t should be equal to 1. And that allows me on the right-hand side, now I have only observables and lambda t plus 1 and lambda t. And that allows me to identify the sequence of lambda t given an initial labor augmenting level, which I got from this normalization. Yes?
I didn't get exactly the core thing because there's exit, right?
Oh, no, but that's why I use the registry. The registry data are very useful because I know exactly which firms. In 2013, I see some firms in the data, and I know which of those firms existed and were operating already in 2012. Good. So they call that's what I call an incumbent. And in 2012, I see a firm operating, and I know from the registry data whether or not that continued to exist also in 2013.
Yeah, okay.
I take that.
You only compare survivors.
I only compare survivors.
I see, got you.
Good. And then once I know lambda t, now comes your question. I have made an assumption about the production function. So this is so this is a good with the decreasing return to scale abstraction. So the price is always 1. So given that I observe value added, I observe capital, and I observe labor, and I have estimated lambda t, and I calibrate rho and eta. That allows me to estimate TRP at the firm level.
So let me rephrase the question.
Yeah.
Now I understand better. So my question is, what would be the type of industrial policy that wouldn't be loaded on wedges, and you would observers would look like a higher TFP, but actually is the government doing something else? Because I think the hope here of the wedges is to capture all the crazy policies the Chinese government did at the time. But I'm wondering is if those wedges can capture all of that or end up being loaded on TFP.
So one thing I don't, so far, I haven't shown you a theory of entry or exit. And you're going to take that as given. So what I like to do is something along the lines of what you said, to really specify, explicit policies and endogenous entry and exit and endogenous the growth of the firm, and ideally do what Diego heroically did yesterday and solve endogenously for the TFP. Now, in this today, I'm just going to take more of a forensic approach instead of a medical approach. So Diego took a medical approach where he said, I'm going to show you how to do it, but I'm just going to observe and try to say exactly where did the growth slowdown come from. And I'm not going to tell you exactly why. So it's going to be, if it is industrial policy that's size-based, then we ought to see very big differences in different size groups. And it turns out that we do that. And I'll also show you some interesting stuff in terms of entry and exit. Good. So when we do that, if I estimate the labor augmenting growth, it's huge in the period 98-07. It's about 17.5% per year. So I have to say, what we calibrate in line with Kjetil, we calibrate data to be 2/3. I think that's probably too low. It should probably be a little larger. Diego argues that it's 0.85, I think. Rho, elasticity substitution between capital and labor is a very important parameter. We take it from people who have estimated Raval model on Chinese data, which find rho to be about 0.6, which sounds a bit low, but given that's what you need in order to explain these huge changes in the labor income share. Okay, if you before 7, labor augmenting growth 5.5. The Higgs neutral growth was 5.6% per year, and the growth in the number of firms was like 12% per year. Real capital 10%, labor 5%, and real output about 19%. Once we go to the period after that, you see that the real growth falls to 1/3. Real growth in output falls to 1/3. Growth in labor becomes negative. Growth in capital falls to 1/2, and also the number of firms. There is a fall in the labor augmenting growth, but the biggest proportional fall somehow comes from the Higgs neutral. And if I split this up, you see that the labor augmenting growth remains high even after 2010, but the Higgs neutral growth falls to 0. So growth becomes more skewed towards labor augmenting after 2010. Perhaps that should be thought of as automation. I don't know. If I do growth accounting, you see that the TFP terms, the productivity terms, account for about half the growth before 07, and the factor inputs for the rest. Once we get to after 07, the Higgs neutral and labor augmenting growth accounts for about 60%. So the growth of factors decline actually after 07, and that's mainly to the role of labor. That labor is moving away from manufacturing. Okay, now I want to. Now I'm going to define. Let me define. So I define the solar residual, if you will. I showed you a formula for it earlier, where we took it was the same formula as Diego had, but we adjusted. We had to adjust for the number of firms.
So, Kjetil,
do that.
Where is the distortion? So
it's going to come. It's going to come. So this is, think of this as a observed solar residual. Now let's take the all firms and split them into groups. For example, incumbents, entry, and exit. And so G represents a group of firms. So ZGT will be the solar residual for that group of firms. And that define omega as quote-unquote weight, which is it's a geometric average of the share of the group D's share of the total number of firms and the share of the inputs. When doing that, it turns out that the TFP contributions are additive. So the aggregate solar residual is equal to the group-specific solar residual weighted by this omega GT. So these omega G's, because it's a geometric sum, they don't sum to exactly 1, but approximately to 1.
So, but this assumes that the resources are efficiently allocated.
No, I'm just looking at whatever. This is an ag thing. I just take all incumbents, for example. I look at the total value added. That's there. I look at the total capital, total labor, and the total number of firms. That tells me that I'm going to show you in a second what
inside the set. Okay, that's fine.
I'm going to show you in a second what's efficient. So now, in fact, so if I instead, so imagine instead solve a problem where I look at the aggregate allocation, aggregate total amount of capital, total amount of labor, and I look at the distribution of TFP. Given the production function, I can solve for the optimum, and that involves I should really.
We don't have workers' comp here.
So the firm level TFP, optimal firm level TFP, is the firm level TFP to the power 1 over 1 minus zeta multiplied by like a Lagrange multiplier, y bar. Or it's the same for all firms. If I solve all this through, I can solve for the efficient solar residual, which is going to be 1 over n, 1 over the total number of firms, times like a geometric sum of the firm level TFP. Okay, so if I just observe the firm level TFP, I can figure out what could maximally be computed using this, produced using this aggregate input and capital and labor, and I can do the same at the group level. So now I calculate a efficient solar residual at the group level, and I similarly I calculate an efficient quote-unquote weight. But the problem here with this efficient weight is that there enters the efficient amount of capital and efficient amount of labor, and I don't observe that. But fortunately, it's possible to solve for those theoretically. And then it turns out that this can be calculated as, this weight can be calculated at the group G's share of the firms times the share of the efficient TFP to the power 8 over 1 minus zeta. And then we still get that the efficient solar residual is equal to this. Good. So now, now I can, it turns out that the realized growth, the growth in the realized, in the solar residual is equal to the growth in the efficient productivity plus the improvement in misallocation. So yt over yt minus 1, that's the observed growth in value added, and y star over y star t minus 1, that's the growth in the efficient, could potentially have been. So this is obviously the efficient minus the observed. That's sorry. The observed divided by the efficient. That's a measure of misallocation. And if this one increases, it means that misallocation falls. Good. So what I can do now is something along the lines of Bailey, Houghton, Campbell, but now allowing for decreasing return to scale, and I can write the observed growth in the solar residual as the incumbent growth, as the growth for incumbents, relative growth for incumbents, plus the reallocation to incumbents, but the contribution that comes from reallocation to incumbents, the contribution from entry, which is going to be positive if entrants have a higher solar residual than the average, and exit. I'm going to get to the efficient in a moment. If we do this, so here, so remember, the growth in the solar residual between 98 and 07, also the Higgs neutral growth was 5.6%. And then, I split this up into these four terms. It's going to be the growth from the incumbents, you see, is larger. The growth from the incumbents, you see, is larger than the total. So the incumbents had just been for the incumbents. The average growth for the incumbents, the growth would actually been slightly larger. This relocation term is very close to zero because there is not much of a change in the amount of resources that go to incumbents. But you see, entry is actually negative, and exit is positive. That's a bit of a surprise, certainly to us. And if we look at the period after 07. What happens is that the Higgs neutral growth falls to about 1%. Most of that is driven by a fall in incumbent growth. There's also a fall in the growth rate of exit. Now I'm going to take each of those terms. I'm going to split those up into an observed growth versus an efficient growth. So I'm going to split the observed growth on the left into an efficient growth plus a reduction in misallocation. I can do that for the incumbent growth, for the reallocation to incumbents, for the entry and the exit. Here is what that says. So remember, we want to explain that all those numbers sum to, for 9807, sum to 5.6%, and that falls to about 1% after 07. So as you can see, if you look at incumbents, the efficient growth for the incumbents is about the same. There's no change. What happens is the contribution from reduction and misallocation is really falling big time. If I look at entry, now instead of having just negative numbers all along, small negative numbers, there is actually a big the efficient contribution. The contribution to the efficient TFP is very high from entry, but the contribution from misallocation is very large and negative. Let's try to understand that in the last couple of minutes. So here I plotted the solar residual for cohorts. So for example, this is for the 1997 cohort. Firms born in 1997. Okay, for each year, I calculate the observed solar residual. And also calculate and as you can see, it goes growing over time. And as new cohorts are born, they are born with a lower solar residual. That happens every year. And that's why entry, if I just look at the contribution of the solar residual growth, entry is negative. Makes sense. But note that once after they're born, they converge very quickly. The entrance growing faster. Solar residual for young firms are going faster than older firms. That explains why incumbents are going so fast. If I instead look at the efficient, you see that new cohorts actually born more efficient. Then the efficient TFP is higher than for incumbents. But over time, the incumbents are catching up. Why is that? Or perhaps exit. Perhaps the exit is not sufficiently selective for the new firms. Perhaps it's the wrong firms that exit, or perhaps the old firms are learning something from the new firms. Regardless, you can see a measure of misallocation is the difference between the dashed and the solid. And as you can see, that distance is falling with age. So that means that if I go here I plotted the observed solar residual divided by the efficient solar residual. So if this number was equal to 1, there would be 0 misallocation. A low number means more misallocation. As you can see, for every cohort, it's rising over time. So misallocation is rising very fast the first couple of years, and then stabilizes. So that's a sense in which perhaps it's not so crazy to assume that the output wedge is constant over time. I did that only to calculate the sequence of lambda. So that assumption has no bearing on these results. So if I go instead to the period after 07, or certainly you can see, I argue that the growth is slowing down from 2011 and onward. And so what happens there, according to these findings, is that also after 2007, new firms are born less productive, the observed solar residual, but the efficient solar residual is higher. But from 2011 and onward, they don't catch up as fast. So it's as if the new cores are born less productive, and it takes much longer time for them to converge. And that's why the reduction in misallocation is going much slower. It's contributing much less to the aggregate TFP growth after 2011. I'm close to out of time. I'm going to skip the stuff on size, but I just want to say in terms of the enter and exit, what we argued is that new firms have lower measured TFP than incumbents, but higher efficient TFP. Good. So then before 2007, we saw that misallocation was falling very sharply over the life cycle. And new firms, they catch up quickly with incumbents measured TFP. And incumbents, they catch up with new firms' efficient TFP. And you get high incumbent growth because of rapid reduction in misallocation for young incumbent firms. After 2011, this first misallocation that linger over the life cycle much longer. So it takes much longer. After 2011, it takes much longer for firms to reach their optimal size. What we need to dig a bit deeper, the next step here would be to build a firm dynamics theory along the lines of what Diego showed yesterday. So what I would need is I need to have positive selection of firms TFP. So because you saw that the new firms have higher TFP than incumbents, so I need positive selection in terms of entry. But then also I need to have depressed measured TFP for new firms. So the way to do it, one way to do it, it would be to say, imagine you enter, you observe what your TFP would be. But you don't know yet what your distortions are going to be. So you make the decision whether to enter before you have seen the distortion. You just know that the first couple of years you will be very distorted. That will generate positive selection so that new firms are going to be more productive. But once they've entered, it's going to look like the observed solar residual is going to be low because there's a lot of distortions that will disappear the first couple of years. I'm done. I'm sorry I went a minute or two over.
So we're going to take a half hour, I guess, coffee break. During that time, Shuttle will be available for autographs and photos. And we'll reconvene at 10:30. Thank you.
So what happened with state-owned enterprises? We didn't talk about it, but this was a big part of the increasing misallocation, right? Before by 2007 or no?
That's right. So I think that after 2007, the allocation, the distinction between state-owned enterprise and non-state-owned enterprise it's less important, but just because they were smaller. But in the so entry and exit, they're going to be so. You could say that it's going to be embedded here. So if you look at, for example, this period, exit contributed to a very large extent to contributed almost 1/3 of the total more than 1/3 of the total Higgs neutron growth. That's a lot. And that happens mostly the first couple of years after 98, and that's the exit of the SOEs. We could have done it explicitly, but they thought that that was a bit too much. When it comes to size, it's similarly the main contribution to growth before 7 came from middle-sized firms. So you think of state-owned firms that are super large, the fall in, to a large extent, the fall in Higgs to growth came from larger firms. So state-owned firms is part of it. Perhaps it would be good to flesh it out a bit more. All right.
So we start this session by a presentation from Andrej Mijakovic from University of Mannheim, and he will tell us about income inequality and
Perfect. Thank you very much for having me. It was a great conference so far. So today I want to talk about consequences of income inequality. So the motivation for this paper comes from the stark rise in income inequality that we've observed in the United States since the 1980s. This has raised all sorts of distributional concerns, but at the same time also been linked to several macroeconomic developments. Prominent examples being the emergence of the savings flood or the secular decline in real interest rates. Now, a common view on how inequality affects aggregates is by raising the level of household asset or savings demand. The underlying idea is pretty simple and based on microdata, which is simply that the rich save more, or saving rates are increasing in permanent income. The idea goes then if inequality goes up, a higher share of aggregate income is held by households with higher saving rates, and therefore also the aggregate demand for savings goes up. Today I want to pursue a related but somewhat different idea, which is that inequality also changes the composition of asset demand between different types of assets. This is also based on a simple micro fact, which is that the rich don't just save more, but they also save in different assets, namely more in risky than in safe assets than the poor. And let me motivate this with some figures. So what you see here is US household wealth relative to income from the Survey of Consumer Finances. And you see that starting from the 80s, that ratio increased by roughly 50% until 2019. So that's what people often have in mind when they think of the savings. What's perhaps a bit less well known is that at the same time also the composition of aggregate household wealth changed. If you look at the orange line, that's the share of risky assets in US household portfolio.
Risk in your book.
Very good. I'm going to adopt a very coarse definition, which is public and private equity. Everything else, I'm going to put into the safe category.
You know, housing is just the big bear roaming around in the forest behind you.
Right. So I would first argue that housing is relatively safer than some of these other risky asset classes. And second, housing is also bought for non-financial reasons. Right? You also get non-monetary benefits of housing, so it's a bit more difficult to think about the risk-return trade-off in this context, I think. But yeah, that's going to be you call it the big bear. Then I'm generally going to consider housing as safe. But you can also make the split across financial wealth only, for example. And you see that the risky share in financial wealth also increased quite substantially over time. Okay. So what am I going to do specifically? I'm going to pursue two questions. The first question is going to be to what extent labor income inequality affects the composition of household asset demand? And if so, I'm going to study what the aggregate implications of this shift in asset demand composition are. I'm going to do that in 3 steps. I'm first going to show you some facts on income inequality and household portfolio composition. Then I'm going to write down a theory that links the demand for risky assets to labor income itself. And that theory is going to be based... Doesn't work, okay. Yeah, I don't think I'm going to use the chair. My legs are not strong enough for that. But But that theory is primarily going to be preference-based in the sense that I'm going to introduce non-authentic wealth preferences, a relatively standard formulation of preferences these days in the study of inequality. And I'm going to show how this preference structure endogenously generates decreasing relative risk aversion. And using that, we're going to show how this relatively simple structure helps match the microevidence on household savings heterogeneity, both in terms of how much households save and in which types of assets households save. And then as the last step, I'm going to develop a quantitative model that features heterogeneous agents with endogenous portfolio choice and heterogeneous firms. I don't want to promise too much on the heterogeneous firm set. It's going to be relatively simple, especially compared to what we've seen so far in this conference. But yeah.
May I call this the Heim model?
The Heim. Can you give me the underlying?
H-A-I-M.
Heim. Okay. I wouldn't. I think it's lacking a bit more.
Heim means life, so this is a good. It's a good name.
Yeah, in what language is that?
Hebrew.
Oh, I didn't know that. Okay. Well, I hope it's going to be lively from now on. So, what I'm going to show within the context of this model is that the rise in labor income inequality essentially makes two predictions. The first is that it's consistent with four quite salient macrofinance trends that we've seen since the 1980s. The first two being that, as I shown before, wealth income ratios in the aggregate have gone up, but also risk-free rates have gone down. This is pretty well known, and that's been linked to inequality before.
But you don't need inequality to get that. Not that when the risk rate goes down, the value of assets go up. So you get it for free, even in a representative income.
Right, but the question is what drives the decrease in the risk-free rate? Right. So all of this is going to be in general equilibrium, just to be clear. The second set of facts is that at the same time, as I showed before, also the risky asset share went up and the risk premium went down. That's going to be the contribution of this model specifically. And then the model is going to make a second prediction, which is about total factor productivity. In my model, aggregate TFP is going to go up as a result of more income inequality because portfolio decisions by households are going to lead to capital reallocations to riskier and more productive firms. Okay.
That's against the data or not? I mean, there's a slowdown of aggregate TFP.
Right, but that's a global slowdown. Okay. So if, for example, you can do some very simple, stupid scatter plots where you just look in the cross-section of countries and compare how much inequality grew compared to how much TFP grew. And you see a relationship that's consistent with that. But I wouldn't use that as...
Sorry, so I thought this is a story about the US, or no? I thought this is a story about the US, and in the US there's just a documented decline in aggregate TFP, no?
Oh yeah, sure. But there could be many other things going on at the same time. So if you only look at the US time series aggregate, you see a divergence between them. Okay. So let me move on. Let me give you very briefly a few empirical facts, motivate further, and then we're going to go into the theory. So the first set of facts I want to show you is about the cross-section of US household portfolios. These are well-known facts, but I want to bring everybody on the same page. So in the left panel, you see wealth-income ratios for different labor income deciles of the US distribution. And on the right-hand side, you see the portfolio shares.
You say it is total wealth, so including housing minus mortgage, and is income before, or is it disposable income, or labor income, or pre-tax income? What is it?
Income is pre-tax income, right? But that's not going to change it. That might affect the ratios, but it's not going to change the ordering on the x-axis. This is net wealth. It includes its total assets minus total debt.
I think it would be nice to do that graph for working age population, because you see the one there, the income, right there is their very little income. They're very rich, but that's not what your paper is about.
So you can run a regression where you include demographics.
Then you're going to get it.
It gets even stronger. Yeah, which I found personally very interesting. There's a big debate in the literature whether it's inequality, whether it's demographics driving these trends. I think people are leaning slightly more towards inequality, but yeah, it's a horse race. All right. So what this is trying to say is that if you compare the top 10% of the distribution to the rest, you see much higher wealth income ratios within those top 10%, roughly double of what the rest of the economy is. When we look at the composition of their portfolios, you see a relatively similar pattern. If you focus first on the blue line, that's the unconditional risky share. That's also increasing in income and has a substantial jump for the top 10%. And I think maybe this is all just driven by some fixed cost of risky asset market participation. Not everybody can invest in equities. Then if you condition on positive amounts of risky assets, you still get this jump for the top 10%. So also conditional risky asset shares are substantially different for the top versus the bottom of the income distribution. Well, this is a snapshot of the US. This has been shown for many other countries. So this is a pretty consistent set of facts. Yes?
So you're saying so the left-hand side gets stronger when you control for age?
Yeah.
That seems good.
I found it surprising too.
Actually, you would think that it's partially an age thing, but it's not.
Yeah. So if you there's some work by Jan Sophie Straub, right, who showed that saving rates across the age distribution are actually relatively similar, and the big gap really opens up for inequality if you compare the top 10% versus the rest. Okay.
Sorry, just one quick question. I didn't quite get it. For the top income decile, are you saying that 60% is still in liquid assets or 60% in liquid assets and housing? I didn't quite get where we got
it. For the top 10%, 40% is in public equity or private business wealth.
And the 60% is liquid assets and housing.
Exactly, that's everything else, yeah.
But on the paper, it turns out if you look at Scandinavian data, and you're going to get the same thing: the higher wealth, higher savings rate. But if you distinguish between, because you want to take out housing, if you take out housing and you recalculate, so imagine you abstract from unrealized capital gains from housing, the savings rate is flat as a pancake, like in the CRA model. And so the question is, is it right to take out unrealized gains in house prices? If house prices go up because people like more to live because of preference shocks, then you shouldn't react. You live in a house and now you feel more like living in it, and that's why the price goes up. There's no reason to trade. It isn't yeah. So that's. It goes very much against the argument that savings are too high for the rich.
I agree. So I think housing is a special case where this argument certainly applies. But you can take out housing here. So maybe what you're saying, I should take it out.
I think housing is part of the story.
Fair. I could do that. I can do that. But just to be clear, also to follow up on what you said, I'm not going to be distinguishing between essentially what are quantity and what are price effects. Okay? I'm mainly going to be thinking about quantities as a baseline. We need a baseline to start thinking about it, further complicating the model. Okay. So this was just a snapshot of the distribution in 2019. So the question is, how does cross-section evolved over time? Okay. What did the top 10% look like in the 80s compared to what they look like today? If you run this comparison and you look at changes in wealth income ratios over time, you see that most of these changes happen at the top of the income distribution. So the top 10% has essentially more wealth relative to income today, versus for the rest of the population, the changes were relatively close to zero. Similar picture emerges for risky asset shares. There, the increase is slightly more broad-based. So essentially across all income details, households are holding more risk, but it's particularly the top 10% that are holding more risk now. And also, if you think about what's driving the aggregate, that essentially comes almost exclusively from the top 10% of the distribution. So these need to be really important guys if we want to understand what's happening at the macro level. Okay. Now, getting causal statements out of, what's the relation between inequality and, aggregate portfolios is quite difficult. One thing that you can do beyond just looking at the aggregate time series for the US is looking at the US state level. So you can construct proxies for household portfolios at the US state level and compare them to inequality levels at the US state levels. And this is what I'm doing here. So again, this is of course very suggestive. It's not necessarily implying a causal interpretation, but it helps set up a broader set of statistics. And so no matter if you look at levels, if you compare top 1% income shares with risky asset shares, or if you look at changes over times, you see a positive correlation in the data, right? Yes.
X-axis is again daily income share, or?
Okay, good point. This is now total income, unfortunately, because I don't have this measure for labor income only. Yeah.
How should we think of labor income risk? Because like this top decile of labor income also faces the more severe downward risk. So maybe it's actually kind of like optimal from whatever perspective of optimality to hold more wealth to insure against this downward risk.
I'm going to be very clear in the model about the distinction between labor income risk and permanent income differences. That's actually going to be key. And I agree that if you just think of the wealth income ratio, that would be a logical conclusion. Rich guys should hold more wealth if they have more risk. But you're going to run into trouble when you start to think about the portfolio composition. Because in principle, if your income is more exposed to risk, you might want to take on less risk on your asset side. And that's the opposite of what we see in the data.
It depends on the correlation between the two risks, right?
Right. And I guess you would say that if anything, income risk at the top is even more correlated with financial returns than at the bottom. So I think all of these alternative stories are actually working against what we see in the data. Okay. So what's the problem with this pattern? The problem is that many canonical models have a very hard time matching the cross-section of household portfolios. The first observation is that the wealth-income ratio is relatively flat across income groups. So you typically need something extra to get the jump for the top 10%. The second observation is that, essentially from the household finance literature, it's very difficult to get this increase in the risky asset share for households, especially once you condition on positive risky assets already. Okay. So the literature saw a lot about number one, how can we get wealth income ratios, and has recently made a big buzz about putting non-homothetic wealth preferences into our standard models. Because these preferences, as I will show you in a bit, help us get the wealth income ratios right for the top of the distribution.
Can I just say, so obviously if you think of the canonical model, CRA with two assets, you're obviously right. But imagine you think of canonical plus as a model where there were some bequest preferences, where somehow you're more linear preferences for bequest.
That's where I'm going.
Okay.
I think there's a bit of a labeling issue, how you want to call certain things. Sure. Maybe you want to ask another question when we get to the map, but...
Shut up.
All right. So what I want to say here is that, well, once you think of a portfolio choice problem of the household, this preference structure also helps you with problem number 2. Okay, and that's what I'm going to show you now. Yeah.
Go ahead.
Correct me if my understanding is wrong. I think what you showed is a share of risky asset, but it could be the case that when I'm poor, I can only invest in one firm. It's very risky. But when I'm rich, high income, I can diversify my portfolio. So I will invest 100 firms. So the share of the risky asset will be high, but it turns out that the effective riskiness is not that high.
Yeah, you're thinking of this differential axis, right?
Yes.
Maybe what's puzzling in the data, though, is that if you look at idiosyncratic risk exposure across the distribution of income, it actually increases income, and it doesn't decrease. So
private business.
Exactly. So if anything, this would again speak against it. Right? And then especially more recently, I think the access costs to ETFs, for example, have been decreased substantially. Yes.
Yeah. So maybe just follow up on this. So I guess one alternative to this would be to model actually ownership of firms. So my reading at least was that, especially at the very right tail, a lot of that is that they are highly exposed because they own a firm, right. And that firm is just doing very well.
Right.
And that's different from this, no?
Yeah. So that's why I focus on the top 10% more than on the top 1%, because I think that's really where this distinction kicks in. Yeah. But in principle, yes. And I think if you read the literature on really top-end income, wealth inequality, it's really about entrepreneurs. I'm kind of gonna put all these guys together. Whether you're investing in a company or whether you're operating a company, these are gonna be the same guys in my world. Okay. So I want to show you a very simple example of portfolio choice with non-homothetic preferences, just to essentially fix ideas of how the quantitative model is going to work. So to start off, I want you to think of the simplest possible portfolio choice problem, where you have an investor with CRA utility that invests some resources Y across a safe and a risky asset, and that's a one-period problem. In this world, the risky share is independent of the amount invested, and it's just a function of the Sharpe ratio, so of the excess return on the risky asset over its variance, times 1 over your risk aversion, 1 over gamma. That's the classic formula of household finance. Now, the question is how this changes once we tweak preferences. In particular, what happens once we add a non-homothetic preference over wealth, where households not only derive utility from consumption, but also utility from wealth. What's important is that this is non-homothetic because the eta, the curvature over wealth, is going to be lower than the gamma, the curvature over consumption. It's also so effectively going to be less risk averse over wealth than over consumption. And that's also going to make wealth a luxury good. So the richer you are, the more wealth you're going to hold relative to what you consume. Now, I'm going to solve a portfolio choice problem here, but not a savings consumption problem. Okay, I'm just going to fix how much of terminal wealth is consumed, how much enters this part, and how much enters this part for the analytical part. Okay? Yes?
So could you also get this from saying there's some attention problem where the rich have an incentive to actually deal with what it takes to set up a stock market account and stuff? Would that give you the same thing and this is just a reduced form? Or?
Not really. So you're thinking about constraints, yeah, right? Well, this is a preference. This is going to be about the risk aversion behavior of. So especially once you go into welfare analysis, it's going to have very different implications. And I think
for the positive analysis, is this just a matter of recalibrating?
So one thing I think this kind of theory is going to struggle with is the change in the cross section, because it's not obvious why the top 10% today would be less subject to these type of frictions than the top 10% 30 years ago. Right? They already hold enough money. They already have enough attention to what I call it, make their optimal investment decision. Yeah.
I have a quick question. I don't really know the literature, but of course you have other choice of the utility function, and because obviously the CRA won't fit. Mm-hmm. But there should be some other choices, obviously, and why these choices are better than the other choice.
So this one is going to help me match two sets of facts. It's going to help me match the portfolio composition, but also the savings level. Mm-hmm. So essentially, get two things in one.
And by the way, the observed bequests. Mm-hmm. Only the rich give bequests.
Exactly. So there are no. You can think of this as it's a one-period problem, so you can give it any interpretation you want here. But yeah. So what do we get when we solve this problem? You do an approximation of the objective function, and you can derive an approximate risky asset share with non-homothetic wealth preferences. And if you compare this somewhat ugly-looking object to what we have up there, its nature is relatively similar, right? The risky asset share is still a function of the excess return over the variance, but now the risk aversion is going to be effectively weighted between your gamma and your eta with some weights attached to it. Okay? So how can we think about this formula more clearly? Let's look at some extreme cases. So let's think about the case where the consumption share is theta. Theta is 0. So all wealth is saved and not consumed. In that case, the formula collapses to the Sharpe ratio times 1 over eta. So the curvature over wealth, not over consumption. You can also think of a second extreme case where the resources invested go towards infinity. In that case, that expression also collapses to Sharpe ratio times 1 over eta. Okay? It's essentially telling you the richer, the wealthier you are, the more of your utility is going to be derived from this component relative to that one, and also so your effective risk aversion is going to change. You can put some numbers on that. You're effectively going to get 2 bounds for your risky asset fraction, where your lower bound is given by the gamma, and the upper bound is given by the E. That's the simple logic of portfolio choice with non-mathematical preference. Now let's get to the quantitative model. So what does it look like? There are essentially 3 main agents in there. There's going to be a continuum of households that makes a decision between putting money in a safe or risky investment technology. And on the asset supply side, I'm going to model it in a very specific way, namely that there's a representative safe firm that provides the safe asset supply, and there's a continuum of risky firms providing the risky assets. Okay? So households are going to demand capital, different types of firms are going to provide capital. In this economy, risk is going to be idiosyncratic and non-diversifiable, so it's not going to be an economy that features aggregate risk. But the assumption of non-diversifiability is going to get me that idiosyncratic risk cannot be diversified away, and you still get a positive risk premium in equilibrium.
So what does diversification mean? I don't get it.
Can you give me one slide, or maybe two, 3 slides or so? And if you want to relate this to some other models out there, you can think of it as a wild mix of Ayagari plus Angelettos plus Ludwigström. It's sort of that.
It could also be counter-cyclical. It could be counter-cyclical. That would kind of give you hedging motive immediately.
Yeah, I have a version. Well, it's a bit difficult to think about cyclicality without aggregate. Well, you can. It's probably not the kosher version, but I have a version of the model where I have some correlation between your labor and your investment returns.
So it doesn't have to be correlated just at the second moment. It's inequality goes up. Or say the conditional variance of the persistent shock is going up. Yeah. There's a lot of evidence for that.
I think people are moving to third moments. They're saying it's really the skewness.
Well, if you look at labor income before tax, you're right. If you look at disposable income, the skewness doesn't move. You ignore the business cycle. But the second moment moves. And arguably, it is disposable income that matters for consumption.
That's a fair point. I'm not going to have any of that. I'm going to keep it very simple with 0 correlation structure. So let me just get into more detail very briefly. So the key points is that households are going to be heterogeneous ex ante in some permanent skill type. I'm going to call this SI, and heterogeneous ex post in their productivity realizations, that IT. And this is what I'm going to use to think about this distinction between permanent income differences and differences in income risk across the history. And then, importantly, households are going to derive some warm glow utility from bequeathing wealth. Okay. So what does this look like formally? This is the household decision problem. Households maximize their value, which is defined over their ability type, their stochastic productivity realization, their wealth. They choose consumption, safe investments, and risky investments, and maximize utility over consumption. That's the standard part, and wealth, which is this non-standard part in orange here. Okay. Now, if you look at this and compare it to what we had before, it's slightly different. Because, first of all, now we have 2 types of assets. In the utility function, I'm going to weight them equally for simplicity. We still have differences in curvature between consumption and wealth. But now we also have this additional, you can think of it as a Stone-Geary shifter inside. This essentially prevents that every household has positive amounts of wealth. Otherwise, you don't get these 0 wealth households. So the idea is that you consume in case you die with some probability 1 minus epsilon, you leave a bequest. And in case you survive, you get some continuation utility. But here, depending on how you think about this dying probability and this weighting parameter, it's really isomorphic between is it a wealth motive or is it a luxury bequest motive. So there are different ways to think about that. Okay, budget constraint is very simple. You consume, save in a safe asset, save in a risky asset. If you save in a risky asset, you still incur some participation cost. You get some income that depends on your permanent productivity type and your transitory productivity type and your wealth from the previous period. Okay? So let me speed up a bit here. So the key thing I want to convey here is that what I'm going to do is I'm going to be changing the distribution of permanent income. So I'm going to make some households permanently richer and some other households permanently poorer. And in this economy, changes in the permanent income distribution are going to act as if you were changing the patience or the risk aversion of a hypothetical representative agent. Okay? That's going to be the idea behind it. So inequality up is going to make the economy effectively more patient and less risk averse. Now, why am I changing this S and not the Z, the income risk, to capture changes in income inequality? Because there's a lot of literature that has shown that most of the rise in inequality in the US has been driven by the permanent component, not so much by changes in income risk. Okay. So, how much time do I have? Not much. One minute. Okay. Okay. So asset supply side, very quickly, there's a standard, very safe firm, right? Essentially a safe production technology. There's going to be a risky production technology, where the risky production technology differs in two ways. First, capital is exposed to shocks, right? That's where I introduce the riskiness, the stochasticity. But these firms are at the same time more productive. Why are they more productive? Well, they need to be if they want to attract investment, right? Investors need to be compensated for carrying additional risk by getting higher returns. Why is this non-diversifiable? Because I'm going to assume that each household can only invest or operate one firm only. So household A can put money in firm A, but not in firm B. Okay, and that's an assumption. Okay, so you can put all these together, you calibrate the model, you compare the portfolio shares and the wealth income ratios between the model and the data across the income distribution, and you see that they match up quite nicely, both in terms of, if you want to call it, saving levels, and in terms of risky asset shares. And then you can use the model to study what the effects of the rise in income inequality were. So I'm going to feed in the income distribution from the 80s and compare it to that of 2019, and then I'm going to compare steady states. Sorry, I have to rush here a little bit, but let me just walk you very briefly through the main results. So what happens in the model is that when income inequality goes up, the wealth income ratio in the aggregate increases, and the risky capital share, risky asset share also increases. And these two account for roughly 1/3 of the rise in those objects that we observe in the data. So inequality explains a non-negligible share, but also not everything. At the same time, safe returns go down, risky returns go down even more, but the average return in the economy goes down less. Because the weights on how much of the average return comes from the safe asset and how much comes from the risky asset change over time due to differences in portfolio composition. Okay, and finally, let me wrap up with this. Aggregate TFP also increases because now more money is flowing into these risky productive technologies that are at the same time more productive. And therefore also in the aggregate, TFP increases. Take this number with a grain of salt. This is rapidly changing over time, depending on the calibration. But I hope to converge to a robust number relatively soon. And I'm out of time, so let me wrap up here. Thank you very much.
Then we now have a discussion by Shubhdeep.
Okay, perfect. Thanks a lot to the organizers, Jeff, Jonas, and Haas for having me, and also Andrej for writing such a nice paper. And I learned a lot from reading it over the last couple of days. So you've seen more or less the main points that Andrej made. There are a lot of things that are really like about the paper. So it links two of these secular trends. There's inequality going up, most of it permanent income. And it leads to a compositional shift from safe to the risky asset share. So he writes a very neat model. He starts the paper with a very simplified version of the model, gives all the mechanics that you need, the bells and whistles to get it right, and then goes on with the quantitative model to then eventually quantify it. So I have not much to say about like the mechanisms that he embeds. So the key highlight of the paper was that there's higher inequality, the portfolio composition shifts towards assets that are more risky, and the risky capital share or the wealth share goes up. So I kind of have not a lot of comments on this. The main comment that I have, which is going to be the bulk of my trying to figure out why it happens, is like, why would simply a change in the permanent income inequality following the first three implications would lead to an aggregate TFP increase? So in a sense, it also is welfare enhancing in its model because output goes up, and it seems to be like if the permanent component holding the mean constant, if I just allocate the human capital assignment differently, holding the amount of human capital constant, that is in some sense good for like welfare, output goes up, TFP goes up. So most of my comments are essentially going to be on the last implication. And so I start with basically what the expected premium in his paper, and it's basically given by this productivity wedge. So there is a safe firm which has some productivity that is normalized to 1, but then all the risky firms have a productivity premium of mu. So the idea is that the household has a portfolio choice. It will put money into the safe asset, get a safe return, but with certain premium, invest in the risky asset. So most of the premium is loaded on the production side. So in a sense, it's not as rich as the asset pricing where the risk itself or the correlation or risk aversion would directly feed on to what the premium would look like. And it basically gets pinned down by the fact that the mu parameter is greater than 1, which gives you a premium. So the main mechanism here was that, well, the analogy in the paper was that, well, if you give money to a big firm like Walmart, it's safe, but if you give money to in a startup, it necessarily gives you a high return with mu. So trying to basically understand the final linkage that there is more supply of risky capital, and that leads to slightly higher TFP. I was thinking about like what in the model could perhaps overturn this result, or if this result has a rich mechanism, or is it an implication of an assumption that, okay, all these risky firms are necessarily more productive. So you can imagine a slightly different version of the model where you say, okay, there is a lottery-like payoff in this situation. So all these risky firms have a productivity premium mu, but you can imagine that with a probability pi, they succeed, and 1 minus pi is the probability of failure. So it's like a lottery. You put your money in this risky venture, but it may not necessarily succeed. So then the idea was to try and see if such a structure, which would nest Andrej's model, because if pi is equal to 1, you essentially say that, okay, all the money that I put in a risky venture is necessarily going to succeed. So once you do that, it's a conjecture, may not be true, but like you can still have expected returns from the risky assets being higher, so there is a premium. But the increase or the compositional shift towards the risky assets may not necessarily increase the TFP. Because once you account for money that you put in and the likelihood of failure and success, you can have that the additional money that goes into the risky firms must also account for the probability of failure. So in a sense, the aggregate TFP would increase if you put money into the risky ventures and they all succeed, but it may not be true if it's a high productive firm, which is essentially a lottery. So this basically boils down to this condition that this additional funds that go in must be going to firms that have a productivity greater than the ZS, which is the safe firm with a normalization of 1. But then if ZS is 1, then you can see that the fact that if mu is always greater than 1, in your model, you would always get that this implication comes from that all the risky firms are necessarily going to succeed. So there is no lottery-like mechanism there. So that was the idea that I was trying to play around, is like, is this final implication that the risky asset share goes up, does it always necessarily imply that output goes up because the aggregate TFP goes up? So I was just like trying to think of like, is there a case or a version of the model where there is a richer mechanism across, say, the distribution of probabilities in which the risky firms succeed or fail, that may overturn this result. So this is just like a bit more of discussion around these lines would help the audience in like getting that main result, because it seems like it seems very important in the sense that just changing the assignment of permanent income can lead to welfare gains. So that was more or less the second comment. The third one has already been brought out, which is about the correlation between the two risks. So if it was positive, then in that case, it is the likelihood that the increase in the risky asset share is going down, because I mean you want to hedge against it, and maybe you want to have a bit more in the safe asset. So that's the third comment. And the last one was essentially that, well, in the data, what you have is like, well, the risky wealth goes up, but you translate it immediately into productive machines. So in reality, what it could be that, yes, the wealth component goes up, but there are two pipelines. Maybe there's a valuation effect, or there is a real effect. And I think in the data, while you have both of those in the model, you necessarily imply that there is no valuation effect. And all of this wealth necessarily goes into machines, and that's more or less it. So in a nutshell, it's a very nice paper in terms of the theory in the initial part. Like, it's very neat, it's very transparent. My only point was like to try and understand a bit more deeply as to like, why does holding the total amount of human capital constant but assigning them differently would lead to output gains and an aggregate TFP effect that is higher. And the intuition that I'm trying to come here is that maybe these risky ventures are not necessarily always going to succeed, or are always more productive than the safe venture, and maybe there is something there in terms of a richer mechanism that may overturn the final implication. So that's more or less it, but yeah, thanks a lot. It was a very nice paper to read. Yeah, thanks.
Do you want to comment? Yeah, I'll be very brief. Thanks for the excellent discussions. I think you touched upon the most important points that the paper still needs to address, which is how to think about the asset supply side. I think there are many decisions you can make on how exactly you're going to model it, how you're going to think about this, how you're going to think about what this underlying excess return actually is. My thinking was, I'm going to start with the simplest possible way of modeling this, which is just essentially having two different types of firms to establish some sort of baseline result, and then use this to think about, what happens when you extend A, what happens when you extend B, and that's certainly on the to-do list. But I agree. Right now, if you wanna, this is probably not the right model to make a direct mapping into the data. I would agree with that. Then on the correlation, that's a complicated animal because it's not. So I guess the main problem is that my risky investments sort of combines both aggregate and idiosyncratic risk, if you wanted to bring it to the data. And these two components of risk are differently correlated with your labor income. And so it's not obvious with this very general formulation of risk how to map it. But yeah, I'm thinking about that. Thank you very much.
Some questions?
So the mechanism here is that the richest are less risk averse, and when they get richer, they get a larger share of total wealth, and the aggregate risk aversion somehow goes down, and that's going to increase their investment in risky assets and lower their risk premium.
10 seconds.
It runs a bit, it sounds like a very attractive idea, except for the fact that it doesn't look like the equity premium has come down, if anything. Since, if anything, the returns, the last risk return, the realized returns the last 20 years have been higher than the previous returns. And if you look at, it could be perhaps that almost a Pearson explanation that we predict year after year low equity premium, and then it keeps being high. And it's not really a critique against your paper, it's more a critique against the literature in general. Everybody thinks that the equity premium should come down, and it keeps staying up. Do you have any?
So I think it's a great point, and
So I think there was a structural break in the data. So the 1980s to the 2000s were very different from what happened after 2000, both in terms of the evolution of income inequality and the evolution of the risk premium. So between the 80s and 2000s, what increased was labor income inequality, but not so much capital income inequality, whereas after the 2000s, most of the rise came from the capital, and not really the labor side. Okay. If you look at the risk premium, there was a drop, well, assuming that there is a good measure of the risk premium, which can also be debated. There was a drop between the 80s and the 2000s, which should be consistent with this theory. And then after 2000, as you pointed out, it started increasing again. But then labor income inequality did not really do much anymore over that period, and I think there were different forces at play. That's my interpretation. So I don't want to take a stance on what happened after the 2000s. I don't know.
We got any other question?
Yeah, for time. So I was wondering, are these preferences sort of these portfolio composition choices on a balanced growth path in the sense? No. Okay.
Okay. It depends on how you express them. So it's not a model of growth. So I just.
But you compare 1980 and.
Right. What you could do is you can express your own preference for wealth relative to some average in the economy. And then I think even if you had growth, you could still have that in there. But at least in the current specification, I didn't need to go that way. So.
Okay, then now let's move to the next presentation. This will be by Yuki Yao from Kent on income tax and entrepreneurship.
Hi, I thank organizers for including a paper in the program. Today I'm presenting this paper, Income Taxes and Entrepreneurship. This is true. I mean, we are still working. This is in work in progress. I welcome all the comments. We're going to work with Bandari, Evans, and McLaughlin. So I want in this. I want to think about the specific type of the business owners in the U.S. So there's the sole proprietors, corporation owners or partners in the partnership. So those are the owners of the firms who actively manage their business, not just some shareholders who just sit on stock. Okay. And those are the center of they are often the center involved. They often appear in the discussion that income taxes for two reasons. First, these owners who actively manage their business owners earn much higher income relative to their peers in their paid employment. First. Second, those business owners or the firms they manage typically a lot of business income in the United States. It's account for around half of the U.S. net business income. And those two facts put them business owner income tax on the private business at the center of the income taxation conversation. At the same time, group of business owners are difficult to analyze for two reasons. First, the reporting issue. It's not central in a paper in this specific project, but it's always a part of the reason for the tax debate. Because typically it is said that it is often the case that those incomes of business incomes are underreported by just immediate underreporting of their income or over expenses. Or it is that around half of their income is not reported roughly. But the second reason, which I think is more important in this project, is that their value of business of this private business is basically built upon their off the book capital investment, which is their what is called a sweat capital, or their effort to expand their business, or could be other intangible, including the client risk or trademarks, or any effort that any owner's effort to expand their business over time. and those are of the books items, so we cannot really, it doesn't really, usually the items do not really show up on the accounting book until this business are actually sold sold on the market. And therefore, it's easy. So those are analyzing those business activities are important, but at the same time, it's a bit difficult. It makes difficult. It is not easy to analyze those businesses. And therefore, we need actual real theory. In this paper, we need to use a theory to study these businesses. Okay. So what we do? What do we do? Okay. So in our paper, in this paper, we develop a theory with occupational choice with business sweat capital. When I say occupational choice, so that we have households, but the household can work for other people, which also work as a paid employee, or they can run their own businesses. So their household can choose to work for other guys or run business. That's occupational choice. And if they are running business, they have to build a business sweat capital. That's where the intangible investment within the private business, including the trademarks or client list or any kind of effort they have to pay to expand the business. In this project, we try to keep the model we aim to build a very canonical model to match all the moments, but at the same time, we try to keep the model very simple. The goal is to have some very simple model, but rich enough so that we can match the data. So to calibrate, we calibrate this model to match the moment to hit both aggregate moment from NIPA plus the administrative data moments from the administrative data compiled by my authors. Okay. And with this model calibrated, the third point and the actual exercise now, in this paper is that with calibrated model, we estimate the optimal tax rate with transitional dynamics. So we studied optimal taxation of business income. And it turns out that if we include the transitional dynamics, part is very important. So it turns out that if we ignore the transitional dynamics after the tax reform, then the optimal tax rate is very different from the optimal tax reform, which accounts for the transitional dynamics. Okay. This is today's plan. Let me first start with theory. So our environment has the model has three components, building blocks. First is first we have two business sectors in our model. One is actively managed businesses or pass-throughs. So we have our own business household who can run the business, and those are business owners who run the business. Those are the other kind of business which is intentionally simple and just a standing representative firm, which is basically which capture the other state corporation, large firms, plus any other government enterprise for calibration purpose. So we group all the government enterprise into this part because we want to capture all the activities in one business activity in one place. And household. Household is central in our program. So households can choose occupational choice, the second part, and they can work for other guys or they can run the business. The running business is the most important part. And they endow with the stochastic abilities or stochastic shocks, like one process we usually use for the IAI model. But importantly, we try to match they face two types of stochastic productivities. Productivity as a worker, like labor productivity, but they are also endowed with some exogenous business productivity. So those are two different types of shocks, and those two types of process has to be separately calibrated. Government part is very simple. Okay? Just they collect the revenues from a tax, labor tax, business tax, plus the consumption tax, and then they spend money to cover the expenditures on goods. services and exchange transfers. So it's very simple, but just clarify still we have to respect the government budget constraint. And we close for any exercise, we adjust the transfer rates so that the budget constraint is closed in each period. And let me first describe the most important part in this model, that is the household problem. And households have a choice of occupation. Okay? So this is a household value function, starting with asset A. And kappa is a sweat capital, which I'm going to explain later. And S is exogenous shocks. And there's C, which is some random case shock. And basically, he can choose he choose the best occupation based on their shock and the state. And if they choose to be a worker, of course they get utility from being worker. And if they choose to be business owner, they get utility from being owner. There's some case shock that Gamble shocks. So actually the decision will be some nice smooth probability to that facilitate computation. But we basically make this size of the Gamble shock very small, that it doesn't carry much economic meaning, but just facilitate computation.
So, I'm confused. So can we go back?
This one.
Yeah, I mean, if you don't have a firm, how do you define sweat capital if you don't have a firm? Imagine I'm employed, I'm a regular, I'm working at the university. So A is my wealth, kappa.
Let me explain this owner's problem first. Okay. And so suppose you are owner, you should be an owner, and then you're gonna have, if this is the owner's problem, and this here, if you choose to be owner, you get the utility from consumption UC minus this utility from building sweat capital, theta of E, plus any continuation value. And the first one, constraint is the budget constraint. So the next period, the asset has to be a gross return, plus the business, after-tax business income. So pi is revenue from the private business. And then the transfer plus minus consumption tax at the new time. And the revenue from revenue is taxed at the business tax tau B. The second part is important, so that this is the low motion for sweat equity. Okay. The next pure sweat equity, kappa prime, is net initial sweat capital, net of depreciation, plus the effort. So if this guy puts more effort, then they can put more, they can build sweat equity. Okay, so yeah, maybe you.
So can you accumulate that? And the way you've written it on the previous slide sort of suggests that you can also accumulate that as a worker.
They cannot, but they can keep. They can.
Okay, so
you can sell it. The answer to Kjetil's question.
Here we don't.
So it depends on what you think, but I would think of sweat capital. So I do a lot of work for my own firm that's not recorded as a capital accumulation, but in reality it is. You talk about customized, but it could also be that I fix the pipes, whatever, or even build part of the house. It could be physical or intangible, who knows. But suppose I sell the firm. Wouldn't I sell also the customer list and kappa with it? Why do you want to say that you keep it? Why don't I sell the kappa if I stop to be an entrepreneur?
We don't. So for simplicity, here we don't have. There's no market, but you can extend the model so that there's a market for the business transfer. Yeah.
There's no market for sweat.
Yeah.
It's inalienable. The sweat capital is inalienable. You can't sell it.
But they can still sell the business as a chunk. And we can think about the market. Here we want to keep the model simple, so we don't think about. Sorry.
Just I want to be on the right page. So here the tau B, that's the tax you're interested in, right?
Tau B is the business tax rate.
That's the one you're interested in, right? That you're going to.
That's the main object here. Yeah.
That one is distortionary here because of the sweat capital, right? Because the sweat capital you cannot you cannot you pay this on profits, but the profits don't. You cannot take out whatever you accumulate on sweat capital from profits, right? That's the reason why this tax is distortionary, right?
Distortion.
That would magnify the distortion.
Beyond this, without this, there's no distortion of that tax, no? Or?
Because of the Lucas firm size model, there's a distortion on that margin too of just participation.
Just clarify, so the third equation defines the revenue, and pi is basically profit, and that's the production function for this private business. So FO, kappa, KB, and B is just a production function which combine the sweat equity kappa, and the KB is the rented capital, and NB is outside labor or hire somebody, and they have to this guy has to hire any rental cost plus the kappa KB minus also they have to pay wage, and that pi is just a revenue profit after paying this cost. Finally, there's also a financial constraint. So this, they may not be able to expand the rent or the capital if the initial asset is small. And the degree of this constraint depends on this chi. Right.
So why do you allow workers to keep the sweat equity? Is it so you can generate like some serial entrepreneurship where someone is an entrepreneur, get like the firm fails, and then later they are more likely to become an entrepreneur again, or why is it done?
Okay. I think it's so the reason is that of course it's they can close, but in general they can close the business, but they can come back, and then we want to have a freedom choice for them to switch the business, but. Maybe that's not
like quantitatively important for your paper, or like
quantitatively it's not. So actually, yeah, okay, it depends. Yeah, so it depends. So this quantitatively we need to have a that's gonna control how they the exit rate or the dynamism moment. So we need to have a moment. We need to introduce some depreciation rate so that's gonna calibrate match the exit rate from this model. But actually now main calibration actually in the main calibration we kind of kill that part, so that's gonna depreciate the process. If in our main calibration, if they exit from the business, that's gonna disappear. But we allow for sorry. Okay.
That's a question to make sure I understand what you're doing. So you just have a standard commodity denarity entrepreneurship model just with endogenous productivity accumulation.
That's one. That's another. So there's another. You can think of it this is plus some extra capital. Okay. So suppose this is a dentist problem. So E is an effort to build a patient list, and the KB is some rented office plus equipment, and the NB is a number of dental hygienist or potentially other dentists. Okay. Workers' problem is simple, and and they basically work for usually just work for other people. The only special thing is here is that potentially they can keep the kappa even though they are not from a previous business, even though they are not working. Okay, but they cannot rebuild the business if they are out of business. And the one moment, so that's how much they can keep how much capital they can keep when they are out of the business depends on this lambda, which which can be which is an important moment for explaining this transition in and out the business, which I'm going to use for data for calibration. Okay. And then we have a corporate sector, which is relatively simple. So basically, we have some dividend maximization program, but basically the corporate sector has here the second the co-product production function, and they use just simple. Basically, that's going to characterized by the first order condition.
How does this F compare to the F of the?
It's very different. Just we use different parameters, so that has nothing to do with private business stuff.
But you could think of an equilibrium in which only the corporate sector should exist, right?
Okay, yeah.
If the function is high enough, then that's where the economy should go.
Yeah. And then actually, so to match the share of business in the national account, we matched actually A to adjust A so that there's enough business in the main calibration.
But another reason could be that if the economy starts with high kappa, that could match what you're saying. But it should be optimal to let that depreciate. And isn't that true? Like you can match what you just said with a high initial kappa, because business owners just start with that, but it's inefficient, or with a high enough, or a low enough A.
So I think
we just start with a lot of people that have small sweat dentists, but because we start with that high kappa, we match what you said, or we could make the A go down so that we have enough sweat dentists, you know.
But here the people business owner has to capital from scratch. So yeah,
we assume that it's in a steady state or something.
Yes, yeah. In the we match the steady state. Yeah, we match the data moments from steady state to the actual data. Mutual fund. I was going to skip mutual fund. So one note about computation. It's a bit hard to compute. So, for example, for the quickly mention, I want to quickly mention the computation issue. That it's a alpha problem is a bit has more than one state, and there's also a non-convexity in the problem. So we need to have a fast algorithm to solve it. Also, we're going to think of the transition. So we use some approximation for the transition dynamics to evaluate the transition in a relatively quick. Relatively fast, not really fast, but it's going to facilitate our analysis. Okay. We want to calibrate this model. How do we calibrate? There's two group of moments. One is that macro moments. The other is a micro moments. Macro is easy, but the micro moment is relatively harder to match. And for the micro moments, we use the business survey census data to study the exit rate, and also the IRS data compiled by my courses to study the business growth of the profit. And we match these moments to discipline our parameters. The key parameters, so we set the tax rate on business is 20%, which is very low different from the statutory rate. Given the degree of reported degree of underreporting or over expenses, we think that the 20% is 20% effective tax rate on business is a good range.
So just to understand, because then you vary the tau B, right? But then if you're saying basically the current one is already not enforced,
it's a hypothetical exercise, but for example, we can do a more serious enforcement. That's going to increase the.
Just a clarification question. So in the beginning, you said something about like optimal tax rates with transition dynamics. Where do we see like which one are you going to find the optimal tax rate for? It's tau B.
Tau B, yeah, that's tau B. Yeah, that's good. For now, today tau B. That is an optimal business income tax rate. Productivity process is matched to the IRS data, and especially the productivity process for business. Z is a crucial part.
But if I sell the business, what's the tax on last capital gains? So if I.
So here we don't study but there'll be a tax, of course.
But isn't that somehow
capital? Doesn't
that go to the core of the issue of sweat capital? So I want to. It's good for me to put my own hours into the firm because it's not taxed. But then if I sell the firm, it's going to be taxed.
Yes.
At some rate, so that's going to be important. However, if I instead just leave it to my son or daughter, then we can do the step up, so I can escape it. Isn't that the reason for why I want to accumulate sweat capital?
That maybe, okay. I think that's an important part. Yeah, true. We abstract here, but I take your comment. We also have a question, and one important calculation target is that the spread depreciation and accumulation, and then the lambda or this utility term function is an important part for that discipline the tax elasticity. We match the to fit the productivity process. We match these three targets. That the top 10% share of the total business income. Those are very highly concentrated. Second, the distribution of income growth we get from IRS data. My authors compiled. The third is the autocorrelation. It turns out we can usually use Gaussian shock innovation to match for this AI1, but it turns out we can only match with Gaussian 1, so we replace this shock epsilon part with rise to the innovation. And especially for this, for now we use what is called exponentially modified Gaussian, which is basically a mixture of Gaussian and exponential shock, which basically looks like this one, so which has a much fatter right tail, which facilitates the calibration. Then we skip the macro, but we do the good job. Okay. Because it's easy, just macro is a momentarily relatively easy, but for the micro, for example, we are still working on it, but we did a relatively good job in terms of profit share. In the data, it's 7%. In the model, we have a 62%, and we relatively do a good job at the both tail of the profit growth. But still, I think we can still improve. Also, we hit the business moment relatively well. Okay, I think it's good. And basically, here we use this table to calibrate the business capital investment building technology. So, for example, because if we change the parameter, basically this exit profile across age is gonna change. But how it changes depends on which parameters you change. For example, if I change the sweat capital deterioration rate for workers, it's going to increase the business exit across ages, and then therefore they're going to be more churning. And that we can use this type of exercise to calibrate the parameters. Let me now jump into the main exercise. So we do the two exercises. One is a transition, right? And then how the economy respond to the tax reform. So at the current calibration is 20%. We're gonna do that to increase the tax rate to the 40%. The effective tax is 40%.
Like, I don't know, empirical studies that you could use as identified moments to compare this type of model to, whether it can be, I mean, I understand that this is an equilibrium model and this is maybe not exactly what you measure in like different studies, but is there like a way of checking what people find? And
yeah. So let me hope I have time, but okay. But first let me look at the transition and compare the two economies. One is the sweat economy without sweat capital. So that abstract, it's not our model, but it's totally abstract on sweat capital. And our model, sweat capital variable model, which is our model. So let's look at the transition. So if we increase the 20% to 40% in an economy which abstract on sweat capital, that the red lines, basically they don't really respond to the tax change. However, in the blue lines, our economy, that really respond to our economy and that respond to the tax change. And if the most important part is the first two panels here. So the economy without sweat capital do not really respond to the tax changes. But the variable economies with sweat capital are going to respond very quickly, relatively quickly in the 10 years. So it's kind of ballpark with our estimated data papers. So that if we measure the model 2 years tax elasticity of the business profit, it's our estimate in the simulated model is 0.64. But from this paper about tax reform, then their estimate in the data is around 0.75. So it's not exactly, we didn't really target seriously, but it's kind of in the ballpark. We use a variable spread economy. Next, the optimal taxation. How much? Maybe 2 minutes. Okay. The optimal taxation. There are many discussion about optimal taxation, but there are many forces to drive the optimal taxation in many directions, opposite ways. One is, okay, if there's more insurance, we need more interest, we need to have a higher tax rate. At the same time, if there's a more misallocation concern, then maybe the optimal tax rate, lower optimal tax rate is maybe welfare improving. So that it's more like optimal tax rate is more like an empirical question. Now we study the optimal tax rate in a fixed economy without sweat and the variable sweat economy with our economy. So if we do the optimal tax exercise in the fixed sweat economy, we find that optimal tax rate 61%, and that's reasonable because it's coming from in the economy without sweat equity, and the elasticity is basically very low, and therefore the optimal tax rate should be very high. On the other hand, in our economy with variable sweat capital, we find that the optimal tax rate is 25%. Okay, we move from here to here. Okay. That's a very different tax rate, and that's once we think about optimal variable sweat capital, then the welfare gain is much smaller, and then the optimal tax, both welfare gain and the optimal tax rate are both much smaller than the economy without sweat capital. So abstraction of sweat capital could be very misleading. Also, we found that if we ignore the transition, I think I have no time, but for example, if we ignore the transition, the welfare gain will be much larger. So it's not good idea. So okay, ignoring the transition dynamics is gonna also overstate the welfare gain and the optimal tax rate. And then basically, rather than looking at practitioners usually look at the Laffer curves, but rather than welfare, we're gonna look at the revenue maximizing tax rate. But it turns out that in our economy, just both welfare maximizing tax rate and the revenue maximizing tax rate is kind of almost same. So it's basically driven this welfare maximizing effect is coming from the Laffer curve or revenue maximizing effect. I think I'm running out of time, so let me conclude. So optimal tax rate there. If you think about the optimal active managed business activity in the US, with their sweat capital accumulation, we find the optimal tax rate is 25%, which is 5% higher than our estimate of effective tax rate on business income, private business income. And that's significantly different from the estimate in the existing literature, which sits around 60%. Okay. And the reason for this gap comes down to three quantitative ingredients. So one is variable sweat capital part is very consequential. So ignoring the sweat capital is gonna basically increase reduce the tax elasticity of business activity. Which is gonna increase the optimal tax rate a lot. Second, the transitional dynamics is also consequential. So abstracting the transitional dynamics is gonna also overstate the optimal tax rate a lot. I didn't have a time, but we also studied how the impact of collateral constraint. We found that it affects the collateral constraint does affect the optimal tax rate because if the collateral constraint is very tight, then that requires then the help in the lowering the tax rate is gonna promote the capital reallocation. But we found that relative to the first two, this collateral constraint concern is less consequential. Okay, thank you.
The discussion will be by Jeff Campbell.
So, thanks to the organizers myself, putting me on the program, and Jonas and Haas, who really did all the work for this. So actually, they deserve a little round of applause. I show up and just look good.
That's what we have you for.
What?
That's why we include you in the organization.
That's exactly right. That's exactly right. So, on that theme, I'm going to use a prop that Gustavo did. And my prop, I'm going to give you a little bit of, I think, nice color for thinking about why this paper is so cool. Okay? And I talked about this with my wife last night. She said that's the way you should start. Why this paper is so cool. And it's because it's about the intersection of three things that really matter in economics. It's about entrepreneurship, which we know is fundamental for growth, and it's fundamental for inequality. And then this paper is also obviously about taxation. And the bottom line of why we tax entrepreneurs is the same reason why bank robbers rob banks. It's because that's where the money is. Okay? And so we need, this paper gets at all three of those. My read of the paper right now is that it is, in the finest sense of Kydland and Prescott, it is a well-tuned laboratory instrument for computational experiments. And my main comments are going to be, the only thing, my job is to request things, and I suppose to complain, but I'm not going to complain. But I am going to request things. My main job is going to be to suggest how we apply the instrument now, and what we should be learning from this. Okay. So my prop is this Adam Smith's other book, which, The Theory of Moral Sentiments, which has a little heart on it that formed from a dollar bill. And this dollar bill comes from the world's greatest central bank research department, the Chicago Fed. It actually says Federal Reserve Bank of Chicago on there.
Really?
Yes. Yes. No, you and I are like, we're in the best place ever. Okay? And so I say that we're in the best place ever. That's not the Fed's opinion. That's my opinion. Okay? Okay. So let me start with a couple of notes from this about entrepreneurship. Okay? He actually talks a lot about great men and men of ambition, and he has entrepreneurs in mind for this. He says, I'm not going to read this. Let me say a couple of things about it, though. His idea of the motivation behind entrepreneurship is that people want to be seen and admired, okay? Either for their consumption or for their great business accomplishments or whatever. They want to be seen. And so that's the first thing. The second thing he says is, none of this is worth it. From a philosophical perspective, you make yourself miserable by trying to achieve greatness. And then this is, the next slide is something I really like. In this, he says, nevertheless, it's this vain reach for greatness that drives us to material prosperity for everybody else. Okay, so what he's saying here, and this goes to why entrepreneurship is so vital, this is actually, there's only two places in Adam Smith's writings where he talks about the invisible hand. And this is one of them. He says, you have people who are going out to try to be hugely successful, and might be hugely successful by, say, making their farm super productive, or to create a new flat pack furniture store, or whatever. And we know for sure that they're going to create great flat pack furniture at the end. Okay, but does that benefit the entrepreneur? No, the one thing we're sure of is that everybody gets good flat pack furniture. What does the entrepreneur get out of it? Maybe a nice painting. And he hangs that up and he says, look, I'm so important, I have the Van Gogh. Okay, but at the end, this is, I think, a nice perspective on the taxation of the ultra-wealthy. That if the ultra-wealthy are working to produce things that everybody needs, that already, in general equilibrium, we know that has to be spread widely, no matter what we do with taxes. Okay, I think it's kind of a nice and neat perspective on this problem. I'm not sure what to do with it at this point, but it's something that you guys could think about. Okay? So that's sort of a background. Now I'm going to get to one complaint, not a complaint, one strong suggestion about the paper. So Yuki put up this stochastic process for productivity that was mixture of a Gaussian distribution and something with a very thick right tail. And that reminded me a lot of conversations with Christina Dinardi when she was working on Kjetil and Dinardi and was battling Eric Hurst and who was saying that there were no financial frictions on entrepreneurs. And Christina said, bullshit, you're mixing people up. There are fake entrepreneurs, she called them. I think we might call them the white van man. Okay, somebody who's just self-employed, but not what Smith would call a man of ambition or a woman of ambition. Okay, these are not people who are going to be driving growth. They're not going to enter the extreme right tail of the distribution, no matter what happens. Okay? And then there are others, there are a minority of the business owners who do and who can enter the right tail. So I put up here pictures of two business owners from Midland, Michigan, which is my parents' hometown. And the business owner on the left is Herbert Dow. Herbert Dow's first laboratory was my great-grandfather's barn. Herbert Dow created Dow Chemical. Okay? The man on the right is my grandfather. He was also an entrepreneur in the data. He had a bowling alley and a liquor store. And in Yuki's model, these are both guys drawing from the same distribution. But they're not. There's no way my grandfather was going to create a large chemical company. He worked at the chemical company on occasion, but he didn't create a chemical company. Okay, Herbert Dow had the brains and the ambition to do it. Okay, and if to reinforce Adam Smith's point, he died from cirrhosis of the liver, right? He drank himself to death. Okay, so my request is at very least you start to think about Christina's distinction between real and fake entrepreneurs. That might only be something for the calibration, okay, that you draw a type. All right. Now let's talk about laboratory work here. Okay, how much time do I have? 1 minute, perfect. I have 4 requests, only 2 of them got up here. What can we use this for? One is something that I would say in the spirit of Rogerson and Prescott, use this as a laboratory for accounting for cross-country differences in entrepreneurship. Okay. So that would require 2 more calibrations. The way I look at the model right now is it's a model that fits a line through 1 point. Now I want to go through 3 points, right? I want to go through 2. That's going to be perfectly fit, and then I want to have a prediction. Okay? I also want to suggest, Yuki and I talked about this yesterday, connecting entrepreneurship to growth in a very reduced form way. Okay, very, very crude. Something like the fraction of the population that's engaged in entrepreneurship has an external effect and creates growth. Okay, I think my hunch is that that kind of connection will have dramatic implications for optimal taxation of entrepreneurship. And then the last one I'll say is in line with Adam Smith's ideas of people of ambition destroy themselves in an effort to be seen. I would like to put keeping up with the Joneses' preferences. Okay, the point of being an entrepreneur is to be seen as so much more successful than those around you. And of course, any kind of crazies out of Berkeley then who are trying to create equality, that's death for that kind of entrepreneurship. Right? Inequality drives growth because whatever inequality we get out is the motivation for the destroying yourself in order to create a new business. So, like I said, I have nothing but praise for the paper as it is. I just want it to expand further. And it's a relatively recent paper, right? You guys have just gotten it started. And so I think there's plenty of room for that. So I'm done. Thank you.
We're running out of time, but it's time for one quick question. Yes. Or if you want to quickly respond.
Thank you.
Sorry, then that Kjetil asked the question.
Quick question. So I think what the experiment you do is to say, oh, I'm going to do once and for all tax change. But so the kind of the standard capital taxation say that the Chandler Judd type suggests that if we could vary that tax rate, it should be zero in the long run. If you had done a Chandler Judd exercise, would you have zero tax also here or not? And if so, why not?
Why not? Okay.
It would be good to tie it, just for the audience, just to tie it to the standard.
The capital taxation, okay.
So I say no, you wouldn't get it.
Yeah, but
just because you're taxing the sweat, you're taxing labor. You're collecting it later by taxing the business output. You can't observe the sweat. But you would like to have an instrument to tax the sweat directly.
But isn't that entrepreneurial ability is like a fixed factor? That you can get that by taxing.
Yes.
Yeah. The sweat is like you call it sweat capital, and you give an example of dentist, but I think that's really misleading because in your model, it's like learning by doing. That's what it is.
Sure,
Keep it. Well, that's what you do with learning by doing.
Not quite, because you have a disutility from the sweat.
Well,
but as you have with learning by doing, if you work harder, you learn more.
Yeah.
Yeah.
Well, but they have to put the labor input. But I understand that it's this capital. It's a bit, maybe the result is very different from the capital taxation, which though is similar. Then I think about how to contrast the result. Yeah.
Okay.